So next speaker will be Mr. Tomogogo from National Tsinghua University. So I think you will speak in English.
Sorry, yes.
I cannot.
No problem.
So
Oh, I can use this? Okay. Thank you very much.
So 我们稍微等一下，等这个投影机热机一下。So we are waiting for the projector. So it's cold. So in several seconds. So no. Okay, so please let's welcome Mr. Tomogogo.
Thank you very much. I'm Tomogogo from National Tsinghua University. Today, I want to introduce a small experiment in my general physics class, developing a digital game-based running system. Before starting, I want to thank my TA. These students worked very hard, and also this work is supported by MOE and NCU Center for Teaching. Let's get started. So, we all have a common program, which is this, right? Do you see that? Do you see this in the class? Maybe not. Okay, we also see this, right? These are my students in the previous department, and eventually it might happen like this. We all have, this is a common problem. So how can we keep students interested in physics? So then, one idea is to use digital game-based learning. Students like games, right? Do you like games? Yes, right? Sure. Do you like games? So students like games. So they get interested, and then they cannot sleep while playing physics games. So that's what it is. So let's focus on, then they might be able to focus on learning physics. So that's the idea. And actually, you may be frowning, some professors may be frowning, you're going to play game in a class? But actually, this is well-studied method. If you are going to the archive and then search for papers about digital game-based learning, you see tons of examples. So this is worldwide, very used method. Let's bring it to Taiwan. And then let's jump into what we did in a class. So the first assignment that I did is I asked students to explore physics games and explain physics in it. One example is here. It's a game called orbital velocity. You go around the game board and then you escape from the Earth's gravity. So that's the game. And then I asked, not just playing, but I asked students to explain physics in it. And then in this case, this student is explaining about the gravity and the escape velocity. So I think that's recent physics, isn't it? And also students enjoy playing the game. Another student introduced this Kerbal Space program. This is like a simulator of a rocket. And then, in this game, you create a rocket and you try to launch it. Okay. And then students even calculate this thrust to weight ratio. Right? This is rocket equation. And then they calculated the rocket equation themselves and then compare to the numbers in the simulator. And then they got consistent number. So I think that's a very good lesson of physics. So that's another example. And they even made me to create a rocket. So this is a rocket that I created, and I happened to, just by chance, made the TW ratio correctly. So this was, I was able to launch this. It was good, nice experience. And the important thing is, no students are sleeping doing this because they like this kind of thing. So that's good. And then, this is a result from the questionnaire at the end of the semester. I asked the student, did you enjoy the learning physics from games? 98% of students said yes. So that's good. One caution is that I was careful with, I tried to give them creative homework to students, because when students present their choice of topic of physics, then they tend to choose to present what they know. And it's more difficult for them to present, explore into what they don't know. So every time I try to, give them additional homework to go in deeper and to dig more into the subject. That's what I was trying to do throughout the semester. Okay, that's first assignment. And then second assignment, I asked them to create their own physics games. And then to my surprise, they did a very good job. So this is one of the games. I brought it here. This is what students said. Physics of poly. That's they created. So in this game, you players go around the board, and then when you stop somewhere, they have this quiz. Oh, thank you, Laoshi. This quiz. And I was, to my surprise, some of the quiz are very advanced. It's a really good physics topic. So I picked an example here. So why are most stars unable to undergo nuclear fusion beyond iron? That's a good question, no? We need to think a little bit or investigate a little to answer the question, right? And if you need to do that to win this game. So I think that's the purpose, when you play the game, you learn physics a little by little. So that's the purpose. And then, of course, when students are creating this game, they also need to investigate answer for these questions, right? And we have plenty of questions here, so that's what they learned in this student learned. So I think that's also a good thing. To create a game, you need to learn physics first. So that's a good part too. This is another example. It's similar, different set of questions. I already shared the quiz. And then this group created a computer game. And in this game, you need to use a gravitational assist to rescue. Okay, in this game, I am here somewhere lost in the space, and then they need to launch a rocket to save me. And to do that, they need to use a gravitational assist. And then they obviously calculated the gravitational assist and they put it in a computer game. So I think that's very good. They did the programming using the Unity. Okay, that's the second thing. The third thing I asked students is to create a quiz about these physics contents. And then at the end of each lecture, every week, we play with all the students, and they see who's number one, who's, Then this is a little bit difficult time for me because I also need to join this quiz, right? And I'm competing with students, and then I'm a teacher, right? So I don't want to lose to students, right? But it's difficult. But then I don't know the question, so I feel what happens to an object's momentum if its mass is doubled while its velocity is constant? A, it remains the same. B, it becomes 0. It's half. It's double. Which is the answer? Double. Oh, okay. Oh, you. 老师，你们很好。Very nice. It was sometimes pressure because sometimes, so at the end, the students show the results, right? And most of the time, okay, to my defense, most of the time I was number one, but sometimes I'm number 3 and some students are above me, so it was a little bit pressure. It's like a test for me, right? So, but again, it was nice too, because when we're trying to answer the question, there are a lot of interactions and discussion among students, including myself. So it was very good. Okay, I should have said that here. So I asked a question: did the quiz in the end of the class, at the end of the class, increase the interaction? And then 92% of students said yes. So it was good, successful. And at the end of the semester, I did a questionnaire to students, and they ask students' opinion. I want to introduce a little bit. So a lot of students, 80% of the students said the interaction between teacher and students are good in my class, so that's good. That's one of the purpose of this experiment. Did you enjoy working at TPS? And then motivation on physics. By the way, this class is a physics class for non-physics major students, so no students are interested in physics at the beginning. But here, almost 70%, 70, right? 70% of students said they are strongly interested or interested, so are motivated. So I think that's good. 94% of students learned something new and it was useful, so that's good. And then, although I don't understand Chinese very well, but this is comparing the results of my class to the all the other class at the NCU. This is my class, and then in most areas, my class is better than the other average of the other class, so that's good. Okay, and then let's look at students' comments. So the professor's departure from traditional textbooks. I hope my directors are not looking at this. I may be scolded. But some other students said, I really like this class format. The new approach in teaching physics is much more interesting. So good. Some students enjoyed this experiment, refreshing experience. So it's good. Okay, then I summarize today's talk. So you introduced this digital game-based learning to my physics class, and the student motivation went up. That's good. And then interaction between students and between students and teachers increased. That's good. Quiz are also helpful. And then this provided, I think, the self-learning opportunity because they need to think about the games and the physics to put in, so they need to think about it themselves. And then one question I noticed is to give suggestion to go deeper or more advanced or better topics. It's very important role myself. I think it. Okay, I showed this pie chart. The question, did you enjoy learning physics from games? And then 98% students said yes. I stop here. Thank you very much for listening. Thank you very much.
Thank you very much for the talk, Professor Yamamoto. Okay, and it's open for questions. Yes, please.
Yes, please. Yes. Professor, thanks for your great talk. I want to ask, is end up in last semester, every student got passed on this course? I mean, is everyone passed this course at the end of the semester?
Well, actually, I think one or two students quit in the middle, yes. But everyone who finished the semester, I passed the class. Yes.
Is it required like a programming language or like need to know classical physics background, then they can use game or something? I mean, do they need Python or C+ to run it on the computer game or field game?
It's not required, but if you want to create a computer-based game, your programming skills are needed, I think. And then some students use that. And then what was the first question?
Do they need to have a little bit like a classical physics?
Okay. That's good. My class is General Physics 2. So actually, I think all the students already passed General Physics 1, so they already have a little bit of background in physics. That's the situation, yes.
I'm wondering about the formation of the class.
Formation, yes.
What departments of the student come from?
This is variety of departments. So this is non-physics major students.
Yeah, they're from College of Literature or from the College of Engineering.
Engineering, a lot of engineering, and then a lot of medical departments, and it's really a mixture. Yes.
Okay. Next.
Any other questions?
Yes, please.
Sorry. I just want to ask a simple question. Did professor also, is this course on the first semester or second semester?
This was this last semester, so is it first semester?
So I may lose it if I were to.
Yes, please, yes.
Is this still, I can get a chance to take the course in NCU for next semester?
Next semester, I don't open a course, but next year.
Okay, thank you.
Yes, welcome. Please, welcome.
Yes.
Yes.
Any other questions? We still have a little bit time.
Yes, thank you.
Do students need to take exams?
No, this
No?
is my exam.
Okay, I see.
So they are happy about it.
Any other questions? Yeah. please.
As far as I know, the general physics B has a whole school test.
Yes,
Am I right?
Yes,
So-
I'm not
so-
joining.
Oh, you're not joining the,
Yes.
the test. Oh,
Yes,
I see.
I'm going independent way. Are you from NCU?
Yeah.
Oh, okay. Small world.
So, any other questions? So, I don't see any. So let's thank Professor Hu again.
Thank you very much.